Welcome, and thank you for joining Arm & Hammer Animal and Fruit Production's webinar titled Minimizing the Impact of Campylobacter in the Integrated Poultry System. We are looking forward to today's discussion on using food safety best practices to help control Campylobacter throughout the poultry industry. A few housekeeping notes before we begin. We're recording today's webinar, and the link to the recording will be emailed to all registrants and attendees afterwards and available on our YouTube channel. Also, please submit questions throughout the presentation. Submissions are anonymous, and we'll address as many of the questions as we can at the end of the presentation. With that, I'd like to introduce our first speaker for this afternoon, Dr. Christine Alvarado, Technical Service Manager, Food Production. Dr. Alvarado is a Food Safety Technical Services Manager at Arm & Hammer Animal and Food Production, where she provides food safety technical support to customers and serves as a technical resource to the poultry sales team. She received her BS in Biomedical Science and MS and PhD in Food Science from Texas A&M University. Previously, she was professor within the Department of Poultry Science at Texas A&M University, an associate professor at Texas Tech University, and an assistant professor at Virginia Tech. During her academic career, she conducted applied research on food safety processing interventions and improving poultry meat quality. In addition, she was an educator for graduate and undergraduate students in poultry science, conducted several industry poultry food safety and meat quality courses, and worked internationally to educate and develop HACCP-based food safety programs in several countries. She has worked in the poultry industry as a quality control superintendent and has extensive knowledge of HACCP implementation. More recently, Dr. Alvarado was a poultry subject matter expert for USDA FSIS in the Office of Policy and Program Development in Washington, D.C. With that, I'd like to turn the floor over to Dr. Alvarado to begin.
Thanks, Steve. I appreciate the introduction, and I hope everyone in the audience is having a good day today. So today we're going to talk about minimizing the impact of Campylobacter in the integrated poultry system. With that, I'm going to just give a quick intro of who Arm & Hammer Animal and Food Production is, talk just a couple of slides about Campylobacter and where we are, then go through some best practices, which are going to include live production, biomapping, multi-hurdle, multi-technology approach to food safety, and just a little bit of data analytics. And then going to turn it over to my amazing colleague, Teresa, who is going to talk about RFCs, and then we'll have some time at the end for question and answers. So Arm & Hammer is really a company that has a true farm to fork approach. And here within our animal and food production group, we have live production, pathogen control for productivity, and we also have pathogen control for food safety. So we encompass that entire integrated spectrum throughout the poultry industry. So with production and processing and with our data analytics team, we truly have that farm to fork approach. So let's talk a little bit about Campylobacter and where we are. It's estimated that it can cause about 1.5 million illnesses a year in the U.S. And according to the Foodborne Diseases Active Surveillance Network, that's Campylobacteriosis is in about 20 of 100,000 people, and many of those, many more cases do go undiagnosed and unreported. As we all know, not everyone goes to the doctor and gets tested and actually comes out with the diagnosis whenever they have any kind of gastrointestinal issues. So a lot of those are probably underreported. We all know that FSIS is currently revising some of the performance standards right now, and so we are currently waiting on where everybody is going to fall within those standards once they do come out. So that's kind of why we wanted to have the webinar today, was really just to talk through some ideas and some thoughts and some things we know that can help processors with control of Campylobacter. So currently, just wanted to bring up that I know a lot of focus over the years has been on Salmonella. Campylobacter is not the same microbe as Salmonella, so what might work for Salmonella may or may not work for Campylobacter, and we've seen that with several products. So Salmonella, our current status is that we've got about greater than 70% plants here in the USDA that are under FSIS inspection are within that category 1 and 2 status. And so we will see where the performance standards are with Campylobacter when they come out to see how plants are doing. But as always, we can always improve food safety systems. So outbreaks that have been caused by Campylobacter, this was the latest from the CDC. Poultry is listed as a common cause of Campylobacter outbreaks. More recently, we've had some liver outbreaks, as everyone is probably aware of from a few years ago. There are other causes of Campylobacter, but poultry is still listed as a major cause of Campylobacter. And if anybody is familiar with the Healthy People 2020 results, we had a target of 8.5 for infections transmitted commonly through food for Campylobacter in general. So this is not specific to poultry, this is across all food, but as Healthy People 2020, we did not meet that. So the red line indicated here is that target, and we have done in the poultry industry a very good job of decreasing Campylobacter, but as an entire food system, we still haven't gotten to the levels of the Healthy People 2020. So, and as I said earlier, we can always improve what we're doing from a food safety perspective. So what are some ways that we can control Campylobacter throughout this integrated poultry system? So I really just wanted to hit on the 4 best practices in food safety and really looking at that systems approach. So these are the 4 that I'm going to talk about in the next few slides. Live production, I think it's important, and I know a lot of companies out there are really looking at live production, and more specifically looking at incoming load and prevalence into the processing plant. And so Teresa's really going to talk quite a bit about live production. I'm just going to hit a few of the highlights, but incoming load and prevalence are going to be key important factors as the chickens and the turkeys come in through the processing plant, so that those antimicrobials can then be effective against pathogens of importance like Campylobacter. A second best practice is really to develop a biomapping program. This would be using microbial testing and really looking at data analysis to understand, and this is Salmonella, but it's really Salmonella and Campylobacter movement throughout the entire production continuum, and to really look at where the hazards are being introduced and what the process control looks like through that biomapping program. The third best practice is really to develop a multi-hurdle, multi-technology approach. And so a lot of times there's one technology that's applied multiple times, and that's not a true multi-hurdle, multi-technology approach. And so the efficacy of that could possibly be improved by adding in new technologies into that control point throughout the spectrum. And then the last thing I'm going to talk about is really data analytics. I've always said that our data, we collect a lot of data at the plants, and our data really holds a lot of the answers that we have. So getting a statistician on board, working with a company to help with the data analytics, and truly looking at that biomapping, truly looking at that multi-hurdle, multi-technology approach, and analyzing the questions that we want to have answered is really an important best practice for food safety. So if we look at best practice number 1, which is live production, as I said, incoming load really does matter, load and prevalence as well. We get asked a lot of questions sometimes about technologies that work in plant A or complex A and don't necessarily work in plant B or complex B, or don't work as well in those there's some differences in efficacy. And so a lot of that has to do with incoming load. And so if we can work or focus on live production and really help to decrease that overall load and that overall prevalence, then it's just going to help the antimicrobials do what they're supposed to do at the plant level. So here in this estimating interventions is just an example of if we have a 51% positive and coming through the slaughter plant, the incoming load 51% positive as it goes through the slaughter facility, the interventions there, especially if they're multi-hurdle, multi-technology approaches, can really significantly decrease that prevalence. However, if we come in with a very, very high prevalence and potentially a high load and a high prevalence, then it becomes a little bit more difficult for those antimicrobials to be as effective. So incoming load, understanding what incoming load is and incoming prevalence is really important when looking at food safety for Campylobacter. Comprehensive multi-hurdle approach, as we said, is also critical because as the interventions are placed throughout the processing plant, interventions can only handle a certain amount of load. And so if we have a lower load coming into the plant, then those antimicrobials are probably going to do a better job and be more efficacious than if they were to come in at a much higher load. So, and as in general with pre-harvest intervention strategy, good management practices, looking at feed, looking at biosecurity controls, pest and rodent controls, litter treatments, as well as some vaccines and feed additives. And as I said earlier, Teresa's really going to talk a little bit more about the pre-harvest intervention strategies. So I just wanted to mention it as a bullet point that good management practices really do make a difference for pathogen control. As far as best practice number 2 is concerned, this is really developing a very strong biomapping program. So having microbial testing, I know a lot of folks do APCs, they can do EBs, there's they can actually look at the pathogen of concern, but whatever it is, just make sure that it's telling you a story. So make sure that you develop a biomapping program, that you have it continuously and ongoing for continuous improvement, and that the data that you gathered can be analyzed and really help solve the food safety issues that you might be seeing in your facility. So understanding that Campylobacter movement from one end of the plant to the other is the point of doing this biomapping program. Also determining process control, so understanding the process, understanding the problem areas. All of that can be done through a good biomapping program, working with someone to understand how many samples do I take, where should I take them, how often should I take them, understanding seasonality, because we do see seasonality differences within these pathogen control steps. And then looking at prevalence and enumeration. And so I know that enumeration can be a little bit more difficult and time consuming to do, but understanding that incoming load as well as that incoming prevalence and looking to see how it shifts can really tell you a lot about what's going on in the process from one plant, beginning of the plant to the end of the plant. So having just a few flocks with very high loads at the beginning of the plant to having more birds with lower loads increases the prevalence, but it can tell you kind of if there's some cross-contamination that's happening and where that's happening, and then you can determine where to address those issues. So load and prevalence can be very important to determine what shifts throughout the process and where the areas of concern can be. So if we just look at a typical slaughter facility, most of the major points of contamination are going to be in that scalding, picking, evisceration, and immersion chilling areas. The cropper is not listed on here, but I do have a slide, I think it's the next slide, that really is going to talk about how the crop can really increase contamination, especially when birds are taken off of feed. So there could be areas within certain areas within different plants that may have different major points of cross-contamination. And that's the point of biomapping, is to really understand where that happens and why it happens and how it happens so that control methods can be placed. So this is the slide I was talking about from Barang and Dickens. Probably some of you have seen this slide already or seen this data or read the paper, but this is Campylobacter recovered from broilers during processing. Multiple sites were tested, and then the enumerated results were reported. And so the picker area is really kind of one of the only areas where Campylobacter is seen to increase throughout the entire process. And so that could be due to many reasons, but the picking area has been known to cause cross-contamination across the birds. As they're moving through the picker, they get squeezed if they're not taken off of feed for enough time, or just in general cross-contamination that can occur. So those are some things to keep an eye on. As I said, the cropper is another area that can cause cross-contamination as well. So typical intervention strategy locations: the post-pick, IOBW, online reprocessing, chiller and pre-chiller area, and then parts are really where most typical intervention strategy locations are found. However, I think it's still important to strategize these locations based on what the biomapping data is telling you, and as far as movement of Campylobacter, both prevalence and load. As far as practice number 3, this is really to develop a multi-hurdle, multi-technology approach to food safety. And as I said earlier, using the same technology throughout the entire process can give you efficacious results. But really, if you introduce multi-hurdle, multi-technology into that process, then it could improve your efficacy and hit certain target areas that may be problematic, especially with Campylobacter. So there's lots of antimicrobials out there. I just listed a few of the big ones here. And so having that multi-hurdle, multi-technology approach, as I said, can improve the efficacy of pathogen control and of reduction of load and prevalence as we go through the process. And we have the bromine technology and the bacteriophage technology that can be used in a multi-hurdle, multi-technology approach. And best practice number 4 is really looking at data analytics. And I think, as I said earlier, this is really where we get a lot of our answers from. I'm not trained in data analytics yes, I have my PhD, but I'm not a PhD statistician. So working with a company, working with a team of statisticians that really understand data analytics and really understand how to use all of that data that's generated in a plant can really target solutions and really refocus food safety within those problematic areas to decrease both load and prevalence. So really, data analytics is really about looking at a systems approach. So building a history, which many of us do. We collect data every day, and we have been for a very long time, since the inception of HACCP. But how are we really building that history? How are we really looking at what changes have we made, and how has that affected our process? How has that affected our food safety? And then looking at those current trends and really understanding what's happening through data analytics before we begin to use predictive modeling. So I know predictive modeling is a big buzzword. If we change this process, how is that going to affect our food safety? And I just am going to challenge everybody to take a step back and really understand what the current food safety trends are within your particular facility before you go and look at some predictive modeling. So this is identifying system deficiencies, looking at building that history and looking at that entire history. We collect a lot of data. This is just an example over a few 2014 to 2017 data. And if we were just to look at this, it would be kind of difficult to understand what is considered to be the average, what is outside of our confidence interval, what are the problem points. And so having someone that really understands data analytics and focusing on identifying the extremes is really important. And so I'm not going to focus on what statistics were used to generate this, but looking at generating an expected average, looking at your 95 and 99.5% bounds, and then you can really determine which of these points are really out of bounds and go back and look at what changes were made and what were the cause of those issues to then prevent those issues from happening again. So looking at changes throughout the system is also very important as we look at the whole systems approach within data analytics. So here, this is complex 1 and complex 2, same company, but 2 different complexes, and we can have food safety results in different complexes, different management, different people, different water. I mean, there's lots of different reasons, but looking to see what each of the complexes is doing and where they're succeeding and where they could probably maybe use some improvement, and looking at the data to show why, to tell the story as to why we're getting better results in one or not as good of results in the other. So in this complex 1, we can really see that the percent positives were much higher within the hatchery, as well as there was not a significant decrease as much during the pre-chill, whereas in complex 2, the live production area is where they saw an increased jump in percent positive. So looking at complexes and what the management is, or maybe what the differences, similarities could be between these 2 complexes through data analytics can then help us focus and determine what steps to take to improve food safety overall. And another point I would like to make about influential metrics is really answering the questions of what keeps you up at night. We really keep, having worked in the industry before, we collect a lot of data and a lot of different points, and having been in QA and QC, the day is spent really just collecting data and just making sure that we're getting the data points that we need and that we've got process control. Simplifying that to what is keeping us up at night and what truly do we want answered to help us improve that food safety, and using data analytics to focus on those influential metrics can be really important. So collecting the source inputs that really affect the outcome is much more important than going out sometimes and collecting a ton of data and then bringing it back in and then not being really able to answer the questions that we need to answer to improve food safety. So if we look at all the different multiple interventions and all the balls that we juggle every day at the plant and focusing them on the ones that really influence the outcomes can give us a little bit more focus and a little bit more structure in the daily activities, and will drive us to help improve food safety. So for example, here is just one example. This particular facility found through data analytics and working with a statistician and working with our statistician actually to look at if they focused on these 3 things, then they would have a 90% negative result in prevalence. However, they only did that 30% of the time. So in the management meetings, they really started focusing on the 3 points that helped them drive negative prevalence, and that helped improve their food safety system. And so that's what is the key to driving important factors. So I only have a couple more slides, but the last thing I really wanted to say was that averages are really great, but variation within each plant is what matters. So looking at multiple complexes and looking at their averages can be important for a company to know, but looking at individual complexes and looking at the individual variation is what really matters. So I guess my final note to you before I get into the conclusion is really managing the variation is much more important than managing the average across the industry, and that will drive food safety. So in conclusion, looking at a systems approach, we all know that pathogens are found in all phases of the integrated system. So really looking at incoming load and prevalence, developing a very strong biomapping system, using multi-hurdle, multi-technology approaches, and using true data analytics can really help drive that food safety program to help control Campylobacter. And then as I have a lot of friends in the audience as attendees, and so for those of you, you already know that probably I'm going to get on my final word soapbox. For those of you that don't, I've been an educator for 20 plus years, and so this is near and dear to my heart. But my final words are really that a complete intervention program begins prior to hatch and ends with proper handling and cooking of the product by the consumer. So education is really key for food safety, whether that be educating your employees, educating your neighbor, educating, retail, restaurant consumers, your, the area where you live. Just educating on food safety is really what's going to, at the end of the result, drive behavior change and help improve food safety. So I just throw out to everyone to look to see, who have you educated today, and kind of throw that out there for everyone to think about. So with that, I'm going to say thank you, and I'm actually going to turn the mic back over to Steve, and I'm going to turn the talk over to my super awesome colleague, Teresa.
Our next speaker is Dr. Teresa Laverne. Dr. Laverne is a monogastric technical services manager at Arm & Hammer Animal and Food Production. She received her bachelor's in animal science from Auburn University, her master's in animal science from Mississippi State University, and her PhD in non-ruminant nutrition from Louisiana State University. She has been a technical services manager since 2016. She provides technical support to customers and enterprise and channel sales teams within Arm & Hammer Animal and Food Production. Previously, she was professor and poultry extension specialist for 16 years at the LSU Ag Center. As poultry extension specialist, she had both adult and youth work responsibilities. In coordination with other LSU Ag Center faculty, she provided educational programs to the poultry industry and growers in the area of nutrient management and regulations, on-farm biosecurity, avian influenza, and poultry production management and techniques. Also, she conducted demonstration trials on alternative litter and mortality management programs. And with that, I'll turn it over to Dr. Laverne.
Thank you, Dr. Larson, and thank you to my awesome colleague, Christine, for setting this up for me to begin. And I guess if you did listen to what was just read, I definitely agree with her on education. We both have that background, and obviously it means a lot, and we really understand that value of education. So I will just say that again: education, education, education. So again, thanks, Christine, for setting this up. Now that we talk on the pre-harvest side, the poultry, of course, unfortunately, whichever way we look at it, are a source of Campylobacter. And the industry has had its focus on post-harvest methods to control and prevent that Campylobacter contamination. But reducing the colonization of Campylobacter pre-harvest in live production is likely to help that post-harvest issue, if there is an issue. So we just have to keep in mind, Campylobacter they do colonize, multiply within that chicken. So whatever we can do pre-harvest to reduce that load, obviously will reduce that load as well as prevalence going into the processing plant. So I'm going to discuss some feed additives that may be used as part of an overall program to reduce Campylobacter load. And again, it is, as she said, a complete program from start to beginning, pre-harvest to post-harvest. So the majority of what I'll present today is related to refined functional carbohydrates, or RFCs, as the feed additive that I'll be discussing. And when we talk about RFCs, first of all, what are they? And where are they derived from? I guess I should start with. Specifically, what I'll be talking about are these RFCs that are obtained from the yeast cell wall, and more specifically from Saccharomyces cerevisiae. And these RFCs are moss, or mannan oligosaccharide, which is a prebiotic, supports the growth of the good or beneficial bacteria. Mannose is also another RFC, and this sugar is what binds pathogenic bacteria like Salmonella or E. coli. Other RFCs are beta-glucans, beta-1,3 and beta-1,6 glucans, which can support the immune system as well as bind mycotoxins. And then there are some other RFCs, or the RFCs can have some effect at preventing protozoa problems or diseases that could be caused by Eimeria or crypto, for example. When we're considering feed additives to put into a program that might be used to reduce Campylobacter pre-harvest, or just for any of the other functions that RFCs can provide, it's important that you have a product that is very effective, of course. And the method in which those RFCs are derived is extremely important. So you end up, or so you get RFCs that are very bioavailable, ideally sized, or that what I mean by that is can optimize the binding sites that might bind the pathogens. So when you're looking for a feed additive of that type, a yeast as an ingredient which can be enzymatically hydrolyzed is good. You're actually obtaining those RFCs through an enzymatic hydrolysis, which is, of course, is a very consistent process. And like I said, can be used to obtain RFCs with an optimum number of binding sites and that are very bioavailable. As an alternative, you wouldn't necessarily want to use RFCs that might be obtained kind of as a secondary product and not the primary ingredients that were being hydrolyzed or being obtained to produce that ingredient. Mode of action. Of course, mode of action and understanding why we want to use an RFC to help reduce pathogen load such as Campylobacter. Okay, it's always important because we have to understand what we're doing and why that feed ingredient or feed additive would be effective. So just to explain a little bit of this, one of the more studied and reported interactions are between gram-negative bacteria with the type 1 fimbriae and mannan oligosaccharides, or moss, and their effects at reducing the colonization in animals. So what I mean by this is when we look at the mode of action, discuss the mode of action of mannose and moss. The mannose is in the intestinal epithelial of poultry, and the pathogen, we can use Salmonella as our example here, can attach to that moss, the mannose specifically within the intestinal epithelial, anchor there, and then of course those bacteria can grow and flourish and colonize right there. But by providing another source of mannose in the gut, that source of mannose can bind or agglutinate the bacteria and prevent them from attaching to that mannose within the intestinal lining or the epithelial cells. So what happens is those pathogens are immobilized or bound by the mannose in whatever source you gave it of mannose. In this case, I'm talking about moss. And then additionally, as a prebiotic, prebiotic effect, those beneficial bacteria can multiply by using that moss as their substrate. So now I'll discuss some of the research that we've been doing in this area as far as using a feed additive, or specifically refined functional carbohydrates feed additive, to determine maybe a mode of action, or work towards determining the mode of action in which this feed additive might reduce Campylobacter load and prevalence. So I have some in vitro work at first that I'll first discuss, and then we'll go into some in vivo trials with turkeys and broilers. So first, the in vitro work. There's actually 3 experiments that I'll present a little data for. And what these were adhesion inhibition assays. So several, like I said, 3 different experiments, but a test article, whether it was a prebiotic or individually or a complete RFC product, was put with, also added with Campylobacter jejuni for co-incubation with a chicken epithelial cell line. And the assays were inhibition assays, so they were looking to see, does that product, feed additive, inhibit the Campylobacter from binding to those epithelial cells. And for the results, the adherent Campylobacter were enumerated, and the prebiotic adhesion inhibition was calculated relative to the untreated untreated cells. Of course, a percentage was calculated for the results. So the first experiment, the first part of this, was a dose study with a complete RFC product. And across, looking at the graph, of course, the x-axis will be the concentration of that complete RFC product. And by the complete product, I mean it was one that contained several RFCs. In this case, it contained moss, mannose, and the beta-glucans. And then on the y-axis, we're looking at the percentage reduction of adhesion. And sorry, I have to move a box out of the way. I can't see my slide. Okay, sorry. So to look on the right, I have a description of the results. And exactly just looking at this graph, we can see that as well. There's a direct dose-dependent effect of the RFC product on reducing the adhesion of Campylobacter to those chicken epithelial cells. So when this RFC product was combined or applied with the Campylobacter and the cells, the Campylobacter was not able to adhere to those cells. So it prevented the adhesion of Campylobacter to those chicken epithelial cells. In the next study, it was not a complete RFC product. It was each of those RFCs individually, and these were actually purified sources. So there was one of the treatments, if you'll call it that, is beta-glucans. Another one was moss, and mannan oligosaccharide, and the third was mannose itself. And then of course there was a control, which was an untreated group. The cells or the Campylobacter was allowed to bind to the cells, adhere to the cells. So when they looked again on the y-axis, again, that represents the reduction or the inhibition. And when you look at how much there was as far as reduction, the highest inhibition or the highest prevention of Campylobacter attaching to or adhering to the chicken epithelial cells was with the beta-glucans. It was beta-1,3 and 1,6 glucans, as well as moss. And mannose was intermediate when you compare that to the other two versus the untreated cells. And then the third part of this experiment was looking at the complete RFC product compared to some other common prebiotics, which were fructo-oligosaccharide or FOS, galacto-oligosaccharide or GOS, and raffinose. And then of course you have your control or untreated group as well. All of the prebiotics and the complete RFC product, all of them were able to inhibit the Campylobacter from adhering to the epithelial cells, especially compared to the untreated, which is what we're comparing to. And then inhibition of Campylobacter was actually greatest by the complete RFC product and the raffinose when FOS and GOS were intermediate. So in conclusion, the complete RFC product, again with beta-glucans, moss, and mannose, and then its components, which are those that I just said, and other prebiotics, the FOS, raffinose, and GOS, all tested here did reduce the adhesion of Campylobacter to those chicken epithelial cell lines. So this can help begin or start to explain a potential mechanism for the reduction in Campylobacter colonization when a feed additive, such as a complete RFC product, is used, or an individual prebiotic, as those that were in that experiment I just talked about. So that was the purpose of this, was to, again, to look at the percent reduction of adhesion, and then again, try to begin to determine the potential mechanisms of action, because Campylobacter is not Salmonella, so there are differences. And now to show you some of the in vivo research using a complete RFC product as the feed additive to reduce Campylobacter prevalence or load. That was the objective here, determining if this RFC product could reduce Campylobacter jejuni colonization in turkey Sika and broiler Sika, as well as litter. For the turkey trial, it was a 16-week growth trial. There were 2 treatment groups, of course, a control group, which did not have any feed additives that would have any effect on controlling Campylobacter. And the other treatment group was fed the complete RFC product at an inclusion rate of 100 grams per metric ton. Throughout the trial, industry conditions were simulated as much as possible, as far as transporting birds from one growth phase to the next, an E. coli challenge, and then at the end of the trial, 16 weeks of age, prevalence of Campylobacter in the Sika were measured. For the 2 broiler trials, they were set up almost exactly the same. The main difference is noted here in the first line, the number of birds per pen. But basically, they were very similar trials. Both went to 42 days of age. Same treatment groups as in the turkey trial, of course, the control, and then the RFC product at 100 grams per ton inclusion rate. At the end of this trial, 42 days of age, Campylobacter jejuni prevalence and enumeration in the Sika, as well as prevalence in the litter, were measured. To look at the data, these next slides will be set up very similar. The light blue colored bar will represent the control birds. The darker blue bar represents those that were on the treatment or the RFC product. The study or trial that the data are from are listed underneath those bars. And in this case, we're looking at cecal prevalence as a percentage. So of course, the percentage of cecal prevalence is represented on the y-axis. In the turkey study, the control group had, I guess, 30 to 35%, it's probably close to 35% prevalence, Campylobacter, whereas those turkeys that were fed the RFC product were closer to a 10% prevalence. And that's, of course, trending if you look at the p-value, trending to a reduction in prevalence. In the first broiler trial, the control group had 100% prevalence of Campylobacter at processing, and the group that was fed the RFC product had an 80% prevalence of Campylobacter at processing. Now, these data are for cecal enumeration of Campylobacter, and these are just the broiler studies. We did not do the cecal enumeration in that turkey trial. So again, same light and dark blue colors. Study is underneath the data, listed underneath the data. And of course, this is enumeration. So on the y-axis will be load in this case and not percentage. The first trial, we had approximately a 6 log load of Campylobacter jejuni in the control birds, and about a 5 log load in those broilers that were fed the RFC product. So about a 1 log reduction in Campylobacter load by feeding the RFCs. In the second trial, very similar results as far as the reduction in load, closer to a 7 log load of the broilers on the control treatment. When we fed the RFCs, you see it's closer to 6. So in both trials, we were able to achieve about a 1 log reduction in Campylobacter load at processing or at 42 days of age. We did also look at litter prevalence of Campylobacter in both of the broiler studies. And just to show you what we saw there, the first trial in the control pens, the birds fed the control diet, all of their pens had 100% prevalence of Campylobacter in the litter. In the second trial, that first trial, those birds that were fed the RFC, their pens of litter had about 50% prevalence. In the second trial, we had 100% prevalence in both of litter prevalence of Campylobacter in both the controls as well as those that were fed the RFCs. So in conclusion, the RFC supplementation to poultry diets can help reduce prevalence as well as load of Campylobacter in the ceca of broilers and turkeys. But again, I just want to re-emphasize that if you're using a feed additive or you're using a plant intervention, that's just one tool. It's an overall approach from beginning to end. And of course, we talk about the same thing with Salmonella. So you can think of that as far as the approach, similar for Campylobacter, in that there's not one magic tool, one intervention that will handle the whole product or the whole problem or reduce the load of either one. It goes back to everything that's been talked about over this webinar, from management, of course, and live production. You have to think about biosecurity as well as have those programs in place. Sanitation, of course, feed additives can be a part of that. And then when you get to the post-harvest side, you've got your multi-hurdle, multi-technology approaches, your plant interventions, and then of course your data, and using that data to understand where the issues are and help correct those. So again, it's another point that we stress is it's not one intervention, one tool. It of course is an entire program to have a effective Campylobacter reduction program from pre-harvest to post-harvest. And with that, we can take any questions that anybody may have.
Thank you, Dr. Laverne. And again, I'll remind everybody that if you have a question, please submit it. We do have our first question, and it is for Dr. Alvarado. It says, Dr. Alvarado, is there currently a bacteriophage intervention against Campylobacter? If so, where is it applied during the process?
That's a really great question. There is not one currently out on the market. Campylobacter, as I believe everybody knows, is tricky. It's a tricky little bug, and so it's not easy to develop. I will say that hopefully, well, I don't even know how to say this. Hopefully, there's some research going on in this area, and that we can have a bacteriophage, because I do believe in the technology against Campylobacter. So, but currently there is not one. Short answer.
Thank you. Question number 2 goes to Dr. Laverne. What is the status on a vaccine development?
A vaccine for Campylobacter, I'm guessing, and yeah, I don't
it
have an
wasn't very
answer
specific, but I assume so. That's what the intent of the question was, Dr. Laverne.
Yeah, I do not have an answer for that. I don't know. I don't know if Dr. Alvarado knows anything different, but I've not heard of anything right now.
Okay, so we'll go to question 3. Dr. Laverne, what's the mode of action for how MOS prevents adhesion of Campylobacter to the intestinal epithelial cells?
Okay, so I was trying to explain some of that. I guess the exact mode of action, the basic science of it, I think we still have a lot to learn. We are just able at this point to say that it in vitro is preventing Campylobacter from adhering to the epithelial cells, but the actual mode of action in which it's not letting it adhere is still something we've got to learn. It's kind of a new area of research, new discoveries occurring. So that's why we go back, I mentioned moss and salmonella, which is much more developed or much clearer mode of action that we understand. It's just Campylobacter, we're working towards that point today.
And similar to that, Dr. Laverne, does all mannose bind pathogenic bacteria via type 1 fimbriae, or would higher mannose content indicate or correlate to more binding?
So, okay. So as far as binding, yes, mannose will bind to the pathogenic bacteria with type 1 fimbriae, right? That's going to bind in a similar manner, whether it's E. coli or salmonella. They have that type 1 fimbriae. That the binding should be similar. And then, could you please repeat the other part of that question?
It just says, would higher mannose content indicate or correlate to more binding?
Okay, so part of that may not be the actual content or amount of mannose. It's going to be more the bioavailability of what is there, which goes back to enzymatically hydrolyzing these RFCs from that yeast cell wall allows them to be more bioavailable and there for the binding to occur. When those RFCs are still intact, or what I mean is still in that cell wall, the binding availability is not going to be as great. So it's hard to put a number that you have to have a certain concentration of an RFC to get the optimum binding, because it's more the bioavailability of those RFCs that are available.
Thank you. Next question is for Dr. Alvarado. Can you give us some examples of the influential metrics that processors should focus on?
So it's individual for, great question, by the way, it's individual for each processor. And this is why working with somebody that understands true data analytics and can look at all the data that's collected at the plants, and then can, I'm just going to call it, do their statistical magic on what those influential metrics is. We have 100 balls in the air, and we collect a lot of data on all those 100 balls. So looking at each of those individual balls, as well as the rules associated with the interaction among all those balls, is really what's going to determine what those influential metrics are. So it's really kind of hard to say these are the top 5, because it really can depend from plant to plant what those influential metrics are. Every facility is going to be a little bit different, but I'll be happy to talk to whoever's question that was in a little bit more depth if you'd like to get in touch with me offline.
Thank you. Here's a question open-ended to both of you. Let's you two decide who wants to answer it, but what differences need to be noted when discussing chicken broilers versus turkeys in regard to Campylobacter?
Teresa, I don't know if you want to talk about the live side of everything, but from the processing perspective of it, there's going to be different performance standards. There's going to be differences associated with sampling methodology. There's going to be differences in load and prevalence coming into the plant. Turkey and chicken are going to be, vastly different. They're still both, Campylobacter is still concerned for both of them. So I think from the processing standpoint, understanding what happens within your facility, whether it is broilers or whether it is turkeys, is what's going to be important as you look at the integrated systems approach. And I don't know, Teresa, if you want to talk about the live side a little bit.
Sure. So your procedures, your management, your interventions are going to be similar between broilers and turkeys for a lot of the same things, right? You're going to have the same feed additives or very similar. You're going to have your biosecurity programs, sanitation. So you're going to do a lot of things pre-harvest similar between the two. But as Dr. Alvarado said, you could have your different standards. You could have your variation in loads between turkeys and broilers that could be different, but what you do pre-harvest is probably going to be very similar, whether it's a turkey or a broiler.
The next question is to Dr. Laverne. Do you see any correlation between enteric health and Campylobacter levels in ceca and on carcass skin?
So that is not something that we have really gotten into looking at yet, and would be definitely a great question, very interesting. It's something I would like to know more about. Campylobacter does not necessarily cause the sickness in the bird. Unfortunately, it's us, the humans, that pay for the Campylobacter. But just overall having a good gut health status is going to help again with any reduction in pathogens of any kind. So it could be correlated. I don't have any definite data to share that, but I guess in generalities, the better the gut health, generally the lower load of pathogens.
This next question is for Dr. Alvarado. From a field implementation standpoint, in most companies, personnel skill sets in a higher level of stats. Therefore, we have a high risk of misusing the data. How does the industry solve this issue of potentially misusing the data?
Sure, that's a really great question. And so I think we try to do a lot of this internally. And I really think that, working with either a data analytics company, working with food safety company, working with a truly trained statistician is really how we answer that question, or a group of statisticians. I know since coming to work for Arm & Hammer, I didn't even realize a lot of this statistics that were out there that could be used to answer some of these questions that I talked about in this. So I know just working with our team of data analytics folks, it has been a huge eye-opener to how pinpointed and focused we can get with our data to answer what keeps us up at night. So my suggestion is to really work with somebody that knows how to use that big data set and data analytics.
Here's one for Dr. Laverne. Were there any positive effects on broiler or turkey performance when Campy loads were reduced?
We do see a tendency or a pretty consistent effect of improved feed conversion. As far as if that's directly related to the Campy, I don't know. That's generally a consistent benefit we get to feeding a yeast culture type product, which is combined with this RFC product. So as far as a direct correlation to Campy, I don't have that information, but that is just the improved nutrient digestibility, improved feed conversion that you get with feeding a product like that is what we see in the research as well, as far as improved performance.
And here's another question for Dr. Laverne. Can you comment on the activity of Rifanos being of equal inhibition?
So I guess my short answer is no. I have not worked with Rifanos, and I was not directly involved with that research trial, so I'm not sure exactly the reason it was chosen, other than it is a common one that could be available as a prebiotic, and one they could obtain to do this in vitro research. But yeah, I mean, it's in the same family. It's sugars, of course, oligosaccharide, just like Phos, Gos, and mannose. But as to why that one was more effective than maybe Phos or Gos, no, I don't have that answer.
Thank you. And here's our last question for today. This goes to Dr. Laverne. Does a water-soluble probiotic work in conjunction with the MOS in the feed?
A water-soluble probiotic along with the moss in the feed.
Yes.
Okay. Yeah, we do, a lot of synergistic effects of using probiotics and prebiotics. And they definitely can work very well. I don't see why, putting them both in the feed versus one in the feed versus one in the water, again, you still have that within that bird's gut that they can work together. So it should be. Again, it's not something that I don't have any data in that regards, as to putting both in the feed versus one in the feed or the water, that I have something concrete to share. But of course, the theory is that yes, they will complement each other. If and again, just make sure your probiotic feeds certain good bacteria in the gut, or excuse me, your prebiotic does. So as long as those bacteria are there to be fed, then yes, you definitely should have the synergistic effect.
Thank you. So that wraps up for today. I want to thank everyone for your attendance and participation in today's webinar.